Welcome to this e-lecture, which is about hypothesis testing and inferential statistics. What is hypothesis testing? Well, we have a sample of units that we want to say something, use to say something about general about the whole population of units. So we want to infer from the sample to the population of units. And the first thing we have to do is to formulate two hypotheses that complement each other based on the property we find interesting in the population. And in our example, we are going to use, our population is Norwegian workers, and we have an assumption that Norwegian workers do not work 37.5 hours a week. And based on this assumption, we formulate an alternative hypothesis, the one we wish to find support for, and a null hypothesis. And our null hypothesis is that Norwegian workers work 37.5 hours a week, and our alternative hypothesis is that Norwegian workers do not work 37.5 hours a week. And note that these two hypotheses, they complement each other. And the null hypothesis is either true or false, and the hypothesis test is supposed to provide the answer to that. So the problem, given that we have a sample to test a hypothesis about the whole population, there is always a risk that our conclusion, or that the conclusion of our test will be incorrect. So we have something called type 1 and type 2 error. And if the null hypothesis is true and the hypothesis test leads to rejection, we make a type 1 error. We are rejecting a true null hypothesis. However, if the null hypothesis is false, but the hypothesis test does not lead to rejection, we make a type 2 error. We keep a false null hypothesis. And when we reject the null hypothesis, we get support for the alternative hypothesis, which is basically the hypothesis we wish to confirm. And based on the principle of making it difficult to verify your own hypothesis is more serious than to make a type 1 error, rejecting a false null hypothesis, then it's to keep a false null hypothesis, which is a type 2 error. Type 1 and type 2 error, if H0 is true and H0 is not rejected, that's a correct conclusion on our test. And if H0 is false but H0 is rejected, that's also a correct conclusion of our test. But if H0 is true and H0 is rejected, that's a type 1 error, and we then keep a false alternative hypothesis and reject a true null hypothesis. But if H0 is false and H0 is not rejected, that's a type 2 error. We keep a false H0, or we reject a true alternative hypothesis. So, hypothesis testing, type 1 and type 2 error. Here, type 1 error, false positive. The doctor tells the man that he's pregnant, which is, of course, not possible. He does keep a false null hypothesis. Whereas he rejects a true null hypothesis. That's so he's rejecting the null hypothesis that you are not pregnant, whereas in the other picture where the doctor tells the woman who is obviously pregnant that you are not pregnant, she's keeping the false null hypothesis, which is of course that the woman is not pregnant. So it's false negative. Yes. And hypothesis testing, level of significance. We have to determine the significance of the test, and the level of the significance is the maximum risk we are willing to take to commit type 1 error. That is to reject a true null hypothesis. So if we set the level of significance to 5%, the likelihood of incorrectly rejecting a true null hypothesis is 5%. And similarly, if we set the level of significance to 1%, it's 1%. So there's always a risk that we are wrong, but we choose ourselves how great that risk is to be. But the stricter, the lower the level of significance, the less likely we are to reject a true null hypothesis, commit a type 1 error. But the stricter, the lower the level of significance, the greater the probability of keeping a false null hypothesis, that's committing a type 2 error. So these two considerations has to be weighed against each other when determining the level of significance. That's our willingness to commit a type, the risk we are willing to take to commit a type 1 error. And we also have to find the probability distribution for the sample results, given that the null hypothesis is true. And the probability distribution gives us an overview of which results are likely and which results are unlikely, given that the null hypothesis is true. And based on the probability distribution, we can determine whether the results we get belongs to the outcomes that are highly unlikely, given that the null hypothesis is true. If we can conclude that the outcome is very unlikely, given that the null hypothesis is true, we reject the null hypothesis and keep alternative hypothesis. And we have already decided what is highly unlikely through the choice of significance level. Yes. So the probability distribution, based on the probability distribution and our chosen level of significance, we have to define the area of rejection for the test. And the rejection area covers or consists of all the outcomes that are highly unlikely, given that the null hypothesis is true. And the sum of likelihood of these outcomes is equal to the level of significance. And the null hypothesis is rejected for values that are unlikely high or unlikely low, given that the null hypothesis is true. So the value that represents the beginning of the rejection area is called the critical limit or rejection limit. And if there are very low values that leads us to reject the null hypothesis, the critical limit or rejection limit is the highest value that gives a rejection. And all values equal to that critical limit or rejection limit or lower lead to rejection. And opposite, if there are high values that leads us to reject the null hypothesis, the critical limit or rejection limit is the lowest value that gives rejection. And all values equal to or higher lead us to reject. The last thing we have to do is to conclude. And our conclusion is based on investigating whether or not the results from the test is in the area of rejection, and that determines the conclusion of the test. If our test leads us to reject the null hypothesis and retain the alternative hypothesis, the conclusion is that Norwegian workers do not work 37.5 hours per week. Because the sample results is very unlikely, given that the null hypothesis is true in the population as a whole. We assume that the null hypothesis is false or incorrect. The association is then significant at the level we have chosen. For example, the number of hours worked by Norwegian workers during a week is significantly different from 37.5 hours at a 5% level. And it's important to note that we get a significant result just means that we can be relatively sure that this is also true in the population. That is, Norwegian employees work more or less than 37.5 hours a week, and with a 5% level of significance level, we are 95% sure that this is true. So this normality curve is our probability distribution, and if we get a result in the gray area, we consider it likely that H0 is true. Whereas if Norwegian workers work very much more than 37.5 hours per week, then we find it very unlikely that they work 37.5 hours. If in our sample they work very much more or very much less than 37.5 hours per week, we reject the null hypothesis that they work 37.5 hours per week in the population as a whole. And this lower area covers 2.5% of the probabilities, and this area covers 2.5%, and in sum that is the area of rejection, and it's 5% of the total area under the curve. So if we get the result that they work very much more or very much less than 37.5 hours per week, we reject the null hypothesis, saying that they work 37.5 hours per week. Well, that was the theory behind hypothesis testing, but there is a simpler life. For many, this can seem a bit confusing, but there's actually a simpler life, and that's the modern hypothesis testing. But what's important to know when you are going to interpret a modern hypothesis test, where you use a statistical software such as SPSS, you also need to know how to compare the probability of significance with your chosen level of significance. And remember that your chosen level of significance is the maximum risk you are willing to take to commit a type 1 error. So the p-value indicates the probability of observing a test with a particular set value or t-value, or higher when H0 is true. So it's really what is the p-value gives you gives you a percentage on the risk of committing a type 1 error, and you can compare that p-value or probability of significance directly with your chosen level of significance. And if the probability of significance is lower than your chosen level of significance, usually then 5%, then you reject the null hypothesis. But if the probability of significance is higher than your chosen level of significance, then the risk of committing a type 1 error is higher than you are willing to take. So then you keep H0 or the null hypothesis. So let's look at how hypothesis testing is done in SPSS. Well, you choose analyze, compare means, and then one sample t-test, for example. And you say that, okay, working hours, that's our test variable, and we want to test whether Norwegian workers work 37.5 hours per week. And you will get this results. And as you can see from this result, this is the p-value, or yes, this is the p-value or probability of significance. And as you can see, this is much lower than our chosen level of significance, which is 0.05%. Or 5%, and so we reject H0, stating that Norwegian employees work 37.5 hours per week, because the sample results are significantly different from 37.5 hours per week. So basically, our test value, this one, we test this value, and we find that the number of hours worked per week of Norwegian workers is significantly different. So we generalize from our sample that Norwegian workers work significantly less or more than 37.5 hours per week. And in this test, actually, they work less, because this is the mean hours of work mean hours of work per week Norwegian workers have reported to work in our sample. So, okay, that was the e-lecture on hypothesis testing. Thank you.